Hello again. We are up to number 17, which involves randomly choosing an XY ordered pair from a part of your XY coordinate axes, coordinate plane, where 0 is less than or equal to X is less than or equal to 1. Also 0 is less than or equal to Y is less than or equal to 1. So it just gives you this little bitty chunk, which I pretty much have drawn out here. We're just picking one from this little section that goes up to the ones enlarged here. That square that I have drawn there, that's the region that we are randomly choosing some ordered pair XY from. And a lot of things in math, if you're doing statistics, you're doing areas under curves, a lot of things are based upon the assumption that you are randomly choosing from here. So every point, this point here is as equally likely to be drawn as that point. And what you do is you break these up into little bitty area chunks. And you say if you have 10,000 of these area points, that one occurs one time in 10,000. And you sort of add up all the different little pieces of area. Do that with calculus. We're not going to do calculus on this. We can do them with geometry if we have nice geometric shapes, which fortunately we do. But you see how many of these little bitty squares you have in the region of concern over your entire region. And you realize that your probability, like in the previous question, number of ways of doing what you're trying to do on top of the fraction. Well, we're trying to draw one of the little bitty area pieces up here. That's what we're trying to draw. And total number of ways of just drawing a little area piece would be all the little area chunks that make up this big square. So when we do the probability, it's going to be the area of concern divided by the total area that we can choose a point from. Because that's all you're doing for all these. You break it up into a little grid. And once you get your little bitty grid, you say, how many of these points total can we choose from? Well, if I did a grid throughout this entire 1 by 1 square, if I just did that entire grid, I could look at it as being an area of 1 square unit because we have a square that's 1 by 1. So probability, fraction, bottom, number of ways of doing what you are doing. There's a little modification. Number of events in the sample space. In this case, what we are doing is randomly choosing one of these little grid points that's inside this square. So we're going to look at that as the area. On top, number of ways of doing what you are trying to do or concerned with. We are concerned with or trying to make sure that our y value is greater than or equal to 2x. I had this line drawn right here. This is the y equals 2x line. We could plot points on it if we wanted to. And just connect the dots. Like, for example, that point right there, that's the origin. It satisfies y equals 2x because if x equals 0, right there, 2 times 0 is 0, so our y value would be 0. That point 0, 0 is on the line y equals 2x. Excuse me. This point right here, where our x value is 1/2, and our y value is 1, it's also on this because if that x is a 1/2, then we have 2 times 1/2. That would be a 1 because 2 times 1/2 is 1. So that would be on that same line. For the greater than part, your y values get larger when you go up. And that's why I drew these upward arrows here. We're doing everything above this line, but we're staying within that 1 by 1 square because they told us that our x and y values are both between 0 and 1. So for us, we're basically saying this here, this triangular region that I'm now shading, that triangular region is the part of this graph where our y value is greater than or equal to 2x. So we're going to change the number of ways of doing what we are trying to do to the area that we are trying to get. And this shaded area divided by the total area, that will represent the probability of randomly choosing some point that happens to be up in this shaded part. It's real similar to the statistics sorts of things where they give you bell curves or other kinds of shapes. And you say the total area of this thing here, forever left and forever right, total area equals 1. And then you look at it and say, well, the area from here to here, that might be 0.10. And that area divided by 1, you just ignore the divided by 1 because you don't need it. So that total area represents a probability, real similar to that basic concept of your areas representing the probabilities. So all we have to do for this question is figure out the area of this triangle and divide it by the total area of the square. And areas of squares, I'm going to call it a rectangle. A square is just a special case of a rectangle. I'll just call it length times width. If I look at the length as being from here to here, that'd be 1 unit. If I look at the width as being this way, width or height, that would also be 1 unit. We're going to get a total area of 1 because we are drawing from somewhere within that. That's the bottom of this fraction. What we are doing is picking a point from that 0, 0 to 1 in both x and y, that 1 by 1 square. We are picking a point. We look at it as being 1 total way of doing it because the area is 1. What we are trying to do is to get this triangle up here. The area of a triangle is 1/2 times length times width, but it's a different length and width. Hopefully you remember that's 1/2. They usually use base times height. For us, if I look at from there to there as being the height, this triangle is 1 unit high. It's 1/2 unit for the base because that x value there of 1/2 is how wide it is right there. So if I put the base up on top, sounds weird, but base on top, we have 1/2 unit, we have 1 unit. So we would get back the 1/2 for our constant. We would get back that. And if I do this, I would get back a 1/4. It's fairly easy to see when I take that same shape. I'm going to draw it fairly quickly here. Going to be a little bit sloppy. If I took that entire square that we are drawing from and that 1/2 base times height comes about from me saying, well, suppose I called it a height, so I'm going to put it here, a base. If I were doing a rectangle, there'd be no problem saying, oh, I'm looking for the base times the height, but we're cutting the rectangle in half. So you get a 1/2 base times height out of it for this part. And I could look at it and say I have 4 identical pieces here because these are identical in shape. We're just taking a couple of rectangles, each of which is identical. So right now you got it cut into 2 equal halves. When I cut each of those into a half on the diagonal, we have 4 equal triangles. We're trying to be in one of them. So I get a 1/4 out of that pretty easily. We're trying to be in this part right here. And that's 1 part out of the equal 4 parts. So anyway, that was number 17. Final answer, 1/4.